I have it. Yeah, I know. I know. Just, Hi everyone, welcome to the Intarea at IETF 98. Myself, Juan Carlos Zúñiga, and Wasim. Hello everyone. We have a packed agenda, so we're going to start right now. Note well. I guess everybody should be familiar with the Note well and the IPR policy of IETF participating to this group. Sorry? Get closer? Okay. I didn't hear. What about the microphone? So, hi everyone. Juan Carlos Zúñiga and Wasim.
Hello, everyone.
Again, note well, please get familiar with the IPR policy of IETF. We have a packed agenda today, so we're going to get going. Minutes are taken. We have a minute taker. Thank you very much, Ian. Your presence is logged, so blue sheets are going around. Please write your name. Recordings and minutes are public, and you have to sign those blue sheets. Does anybody can help with the Jabber? Does anyone? You have a Jabber scribe, please?
Oh, thank you.
Yes. Could we have your name, please? Tal Mizrahi. Thank you very much. Much appreciated. So the agenda, as I said, quite packed. We're going to go through the bashing. Then we are going to talk about the liaison that we got from IEEE 802.1 on the IP over partially partitioned links. Is Eric in the room? Okay, that may be an issue. There is Eric in the room now. Perfect. Then we have extended ping with Ron, IP tunnels. Mark will actually be moved down to the end because he has a conflict at that exact time. Then Tom will give us an update about GUI and extensions. Myself, I'm going to talk about the multicast over IEEE 802 wireless draft. Then Carlos is going to give us some results and an overview of a multicast test bed that they have at the University of Madrid. Proposals to discover provisioning domains from Eric. Khaled is going to talk about IPv10, DHCPv6 options for discovery, 1964 prefixes, Jordi. SDN multicast overlay Nabil, and Hanu is going to talk about the MAMS control protocol. Yes.
Yes, Francis Dupont. I have a concern about the IPv10 presentation. I believe we give the wrong message to the community accepting to do an official presentation here. To summary, we are not satellite.
Okay, so I think it's fair to have the discussion in the group, and that's why we want to have the presenter give the opportunity to give his views, but definitely we will talk about it at that agenda time. Yes,
Suresh Krishnan. So, Francis, I think that's a very fair point. And the idea is like to give him a shot at explaining what this is about, because this has been like kind of lingering around in like multiple working groups. And so multiple chairs in Intarea have gotten slot requests for this. And so the idea is to see if there's anything there or not. Like from the draft, it doesn't look like there is, but I think we need to hear him out.
Okay. Right. And by the way, I think there might be someone online. If you can mute your phones, your mics, because we get some feedback. All right, you want to give the status update?
Okay, so a status update, a quick summary. We have the current hostname practice considered harmful, published as informational RFC. Congratulations. And we have the privacy consideration for IP broadcast and multicast. We initiated a working group last call, which ended on March 20th. The generic UDP encapsulation is now a working group item, but note that this has been inherited from NB03, so that's why we didn't go in the normal way to ask for a working group adoption. And we started a working group last call on IP over intentionally partitioned links, and in January, on January 19th. And this is still open, actually, and we're going to have a quick discussion about it after the presentation.
Okay, thanks. Okay, so the next item is, I think, the liaison, right? So next item in the agenda, this is the liaison that we got from IEEE 802.1 working group. It's about the relationship between IEEE 802.1Q and the draft that we have from Eric that we have reviewed. So Glenn, would you please give us an overview of the liaison and what it's about? Yes, please.
Stand in the box. I'll move the mic back so I can stand in the box. Now I'm in the pink box. Okay, good afternoon, folks. My name is Glenn Parsons. I'm with Ericsson, but in this capacity, I'm representing the IEEE 802.1 working group, of which I'm the chair of that group. And this is a liaison that we sent to IETF and the Intarea working group as a result of us becoming aware of the request to make this document, draft Nordmark Intarea IPPL, a working group document. And in our review of this particular draft talks about IEEE 802.1Q bridges. And the way that it talks about it is, I guess, somewhat confusing to us, because I guess there's two ways that you could write the standard. You could write it as a profile that's more, focused towards how an operator, how a customer would deploy it, or you could, I guess, write it as a standard, which should be, mandatory language on how an implementation of a 802.1Q bridge would be built. And the way that it's written right now, it can be easily confused that this is trying to be a standard that has normative constraints on implementing .1Q bridges, and we don't think that's appropriate for IETF to do. However, we think that this is still a valuable document, because what it describes is the quote-unquote private VLAN configuration of 802.1Q bridges, and we've described that within our .1Q standard. We called it generically asymmetric VLANs, and this private VLAN concept that's described in the draft is effectively an implementation of asymmetric VLANs plus our routed multi-point connectivity, and we've got some description of how that configuration is organized, and sort of the appendix to this liaison. We have an annex within the 802.1Q standard that describes asymmetric VLANs and how it could be configured to support that. And I think, and our view is that this draft is a further clarification of such configuration. And so what our proposal is that if this group supports this as a working group document and progresses it, what we would like to see, what we would suggest is that the tone of the draft be changed somewhat to focus more on how routers can take advantage of asymmetric VLAN features offered by .1Q bridges. And further that the section that talks about 802.1Q should actually reference 802.1Q in a normative fashion and describe, I guess, how it works without conformant language on 802.1Q bridges are built in such a way. So that's the high level ask of and our reaction to this draft. If you continue to scroll down, we have additional information on how how this could be described. So we have managed objects described in our clause 12 of 802.1Q, and we have some details here on how the private VLAN, how we think the private VLAN concept could be implemented with direct references to the 802.1Q standard, and we offer that for your consideration. So, thank you.
Thank you very much. We have a question from Lorenzo.
Yeah, Lorenzo Coliti. I think having just refreshed my memory of this particular draft, it seems to me that there really shouldn't be any conflict in the sense that it should be clarified that the recommendations in the draft are simply about how IP, IPv4 and IPv6 should be made to work on on this type of network, and that seems to me that's something that the IETF should define.
Yes, yes,
right,
and that's
so,
fine.
So where it says here, the fact that there's must and should there, it's just I think it's fine to keep those musts in there as long as they can be in no way construed on to mean what the layer 2 should be doing, right?
Well, and so that's the problem that we had with the draft. In our reading of it, with our particular rose-colored glasses, we viewed it as constraints on layer 2 802.1Q bridges.
Yeah, I mean,
and so with an IP with an IETF rose-colored glasses, you would have the other view. So what we're looking for is language to make it clear that what you intended. So
yeah, so Eric, not Mark. So I think it's very good that you guys have spent time on figuring out what the actual description of the mapping is, and there are two must or must nots in the section that talks about bridges, right? I assume that those were the ones that
yes.
is the main issue here. And then, but I think it would be very useful if you can take the text that's in this liaison and actually include that in the document, because part of the challenge here, which was part of my challenge, was the mapping from what industry uses in terms of PVLAN terminology to the appendix in the 802.1Q spec that talks about some of the things not using any similar terminology.
Right.
And then the actual clauses in the normative part of the spec, right, which is all about the mechanisms. So if we can have that, include this stuff, and I don't know, as I asked on the list, right?
yes,
Are we
so,
free to do that?
yes,
And,
no, I mean that was our intent in providing this
Okay.
text. Is that it's for your, if you think this is helpful in your draft,
Yeah.
you can use it.
and then the other minor question is, yes, as we do that, who do we acknowledge as having contributed this stuff? Is it the committee? Is it
Also,
individuals?
this liaison, this entire text was approved by the committee. So the default would be this is the committee's
Okay.
view, but there were several people who were key in contributing to that, and one is coming to the mic right now.
Yeah, the intent of the document was perfectly clear. And
Could we have your name, please?
Norman Finn, Huawei. We were, it was obvious what the intent of the document was. And if you put on the right rose-colored glasses, as Glenn said, if you can scan down a little, move down,
Can you scroll down a bit
scroll.
on the liaison?
There we go. If it's useful to you, and it may be, we have then sort of as an appendix to the liaison, the details of how you configure a bridge to do exactly what you want it to do. And we thought that may be helpful either, in your appendix or whatever. If you find that helpful, feel free to use it. Steve Haddock and I put that together. So if you use that stuff, we'd be the right guys to reference.
Okay. Thank you very much.
You asked as individuals or as a committee. I think as individuals because we put that in there, but
Well, yeah, so
whatever.
So Norm wants to be referenced as an individual,
Just-
that's fine, but
Just that last part with the details, if
Yes.
you use that.
yeah, but I think it's still worthwhile to reference the 802.1 committee since we sent the liaison, so that's.
Okay, so
Thank you.
thanks a lot, Glenn and everyone else. So definitely there's interest and there's a relevance of this draft. So I guess we are going to, first of all, adopt it, and then we encourage, of course, the author to take into consideration all this fruitful feedback. But we're going to be progressing this document, taking this feedback into account. So next is Ron.
Hello, Ron Bonica, and I'm here to talk about extended ping. And if we can go on to the first slide. Okay, we'll start by talking about your old friend ping. Ping is a lightweight tool that we use to probe the liveness of a remote interface. It's nice and lightweight. There's no credentials, no logging in, anything like that. It relies on ICMP echo and echo reply. And it doesn't actually exercise the interface whose status you're probing. The echo can come in a different interface, the reply can go out a different interface. And it requires reachability between the probing node and the probed interface. That's important. It requires reachability between the probing node and the probed interface. And in the words of a notable sad. So let's go on to the next slide. Let's talk a little bit about your new friend, extended ping. Extended ping doesn't require reachability between the probing node and the probed interface. However, it does require reachability between the probing node and any interface that is local to the probed interface. So what exactly do we mean by that? Let's say I'm on a node, I'm looking at a router that has a loopback that I can reach and a bunch of other interfaces that I cannot reach. With ping, I cannot probe the status of those other interfaces, the interfaces other than the loopback. With xping, I can probe the status of any interface on that box, even though I can only reach the loopback. So xping is applicable in situations where the probing node has a route to one interface, but not necessarily the probed interface. And in all of these scenarios where xping is applicable, the probed interface is not local to the probing node. If it were local, the local node would have a direct route. Next slide. So what are some scenarios in which xping is really helpful? Well, let's take a look at scenario one. The node that xping is running on supports v4. A router loopback interface is numbered from global v4 global space, but all of the other interfaces, A through Z, are unnumbered. You want to probe the status of interface A. Well, you can't do that with ping. You can do it with xping. Let's take a look at scenario two. It's very similar. The probing node is v6 aware. The router that you're probing has a global v6 address on the loopback, but interfaces A through Z only have link locals. You want to probe A through Z. You can't do it with ping. You can do it with xping. Excuse me? Yeah, it's true if it's a ULA. I just used link local as an example. And now on to the next slide. The third example, xping is dual stack. It supports v4 or v6. All router interfaces are numbered with, I can't read the slide, it's either v4 or v6 or both, doesn't matter. But only the loopback address is advertised into any routing protocols. So the probing node doesn't have a route to the probed interfaces, but it does have a route to the loopback. In this case, xping works, ping does not. So next slide. How exactly does xping work? Well, we have two new ICMP messages, an extended echo and an extended echo reply. They both distinguish between the destination address the address to which you send the ICMP message, and, well, the destination interface and the probed interface. You send the ICMP message to the destination interface, and the ICMP message includes an identifier of the probed interface. And all of these ICMP messages are defined for IPv4 and IPv6. Next slide. So let's talk a little bit about the echo request message. It's embedded in an IP header. The source address is the source from which the message is sent. The destination address in the IP header is the destination interface on the node that you are sending the request to. It's the one that you must be able to reach. In the ICMP message, there's a new type going to be defined by IANA. The code, checksum, identifier, sequence number, they're all the same as the ICMP echo request. What's different is you have an ICMP extension structure that identifies the probed interface. So you're sending the ICMP message to the destination interface, and that extension structure tells you which interface the probed interface is. Next slide. Okay. The extension structure contains one or more interface identifier objects. And each interface identifier object can identify the probed interface by index, name, or address. When the interface identifier identifies the probed interface by address, it doesn't need to be the same address family as the destination address. So let's say for a minute that you're sending an ICMP v4 message. The destination interface is an IPv4 address. The probed interface might be identified by IPv6 address, or it might be identified by its MAC address. It doesn't necessarily have to be identified by an IPv4 address. This gives rise to a whole bunch of new use cases. In most cases, a single interface identifier is enough to identify the probed interface. In some corner cases, you need two. For instance, let's say the probed interface is identified by link local address. Well, two interfaces on a single box might have the same link local address, so you might need two interface identifier objects. Next slide. The reply message should give you exactly two pieces of information: the operational status of the probed interface and what protocols are active on the probed interface, v4, v6, both, neither. It will not give you any other information about the probed interface. It's not going to tell you it's an admin status, it's MTU, forwarding statistics, any of the other stuff that people thought might be cool to throw in this. We decided not to, for security reasons, also because we don't want to go into competition with SNMP or any other management protocol. This is just a ping lookalike. Next slide. Okay, this is a view of, we prototyped this, and this is what a view of XPing looks like. You know, you XPing something, you give it the destination interface and the probed interface, and it sends back, yes, I did get a response from the probed interface. These are the two protocols that are active. In this case, we're probing by, whoops. Oh, yes, we are. We're probing by interface name. We're probing, we're sending a packet to 10.10.10.2 and asking about the status of GE000, which may or may not be the same interface as 10.10.10.2. Next slide. Here, we probe by a link local address. We're sending the packet to 10.10.10.2, which in this case was a link local, and we're asking about another interface whose link local address was FE, I can't read it, but whatever it is. Next slide. So there are some security considerations here. If we were only probing by address, things would be fine, but there's also this ability to probe by name. So you could use XPing to discover the names of interfaces on a box. Well, once you know the names of interfaces on a box, you know things like what the vendor is, maybe what version of code he's running. Yes?
Can you go back one slide?
Sure. Okay.
So
If I get that,
Could you have your name?
hi, I'm Bob Hinden. Sorry. If I get that correctly, when you probe FE80::1, there may be multiple interfaces that have that linked local address.
Yes, in this case, on this one particular router, there's only one, and you got an answer. If there had been two, you would have gotten an error message back saying, I'm sorry, there are two such interfaces on this box. Please give me some more information so I know which one you're talking about.
Okay, or you could give, I guess you could return for Paul.
I'm sorry. I didn't
Or
hear you.
you could provide feedback on both or multiple.
We thought about that, but there were security considerations. You might use it to discover stuff, so we got paranoid and
Some
said we'd
people
send
are
an
going to
error.
think you're already way over that line here.
Okay. Anyhow, going to the next slide. Okay, so if you're probing by name, you can discover names, and then you can discover other stuff. For instance, if you see the name is FE000, you know it's a Juniper, you know that it's fast Ethernet, so it's either 10 or 100 megabits. You probably know the MTU, and you don't want to discover that sort of stuff. So we need some mitigations. Next slide. By default, routers disable the ICMP extended echo message. You have to enable it on purpose. If you enable it, you enable queries by type. Maybe you only support queries by address. Maybe you only support them by name. Maybe you only support them by IF index. But you decide which ones you support, and that's a manual operation. It's not by default all on. Not manual, but it's a configured operation. Then let's say you've decided, yes, I will accept queries by address only. The next thing you can configure is I will only accept queries by address, and then only if the source address of the query is from these particular prefixes. So you won't accept it from everyone on the planet. Anyhow, next. The status. We've addressed many comments thanks to Jonathan Looney. We have a complete prototype thanks to Reggie Thomas. We have two new co-authors, Jen Lenkova and Chris Leonard, who I think are both here. Raise your hands, say hi. And that brings us to our next steps. Well, this is kind of a dull draft. What we'd like to do is have a little vigorous, impassioned debate marked by, you know, a little polarization and name calling and gratuitous scandal to keep it interesting. No, just kidding, guys. And then we'd like a call for adoption.
I hope, a non-scandalous question. If you go back a couple slides to the,
Oh, we were hoping for scandal. Sure.
well, we can do that too. The V4 and V6 active. Does this? I haven't read the draft. Does it define?
Which
Sorry,
slide?
sorry. Eric Osborne, level 3. Does the draft talk about what active actually means? Because I could see different response codes from different vendors, where sometimes active means configured, and sometimes it's up, and sometimes it's half.
Oh, operationally up.
Does it define what that means?
We should probably be a little more careful about that. We should probably steal the definition from maybe MIB2.
As
I'll
long
do
as
that.
everyone who ships this means the same thing.
Next version,
I
I'll
think
do
this
that.
is a pretty cool tool. If it's,
Thank you.
If it's that ubiquitous.
And I'll make sure to go to the minutes. Do I add that? So I add that in the next version. Thank you.
Yeah, Suresh Krishnan, I have one concern, right? So we already have heard a lot of reports of ICMP v6 messages getting filtered everywhere, even stuff like packet to bigs getting filtered, right? What are the odds of this actually making it on the internet with a new message code, message type, right? I'm just trying to figure out how do you see the adoption of this happening? And the second follow-up point for that, I would really like this to run by some ops group, probably V6 ops or OpsOrg or both, just to get the operational feedback as well.
Okay, glad to run it by V6 Ops and maybe Ops Area Working Group. As for it being filtered, the target of this, the guy who should be doing the filtering, is the destination. Transit devices shouldn't be filtering this at all because they have nothing to lose by passing it. And since by default it's turned off, the transit really shouldn't. Now, yes, it might, and if that happens, well, we have a problem.
So I think probably a tighter applicability statement for this might be useful, in the draft. I couldn't find one in the draft.
Okay, Eric Vink. And by the way, I like it because it helps for RSC 7404 when we use the link local address stuff. Now, I just wonder, what if you exping a multicast address? What's the expected behavior?
We had some back and forth about this. In one version of the draft, multicast addresses were not allowed, period. Then we decided, let's allow them exactly the way current ping does, and we will get exactly the same behavior. I'm not sure if that's a good thing, and I'm open to a little impassioned debate and polarization around that.
Yeah, because you can reply for each and every interface.
Well, let me
being a member of this group, right?
let me poll you personally for an opinion. Which side do you fall on? We shouldn't allow it at all, or we should let it happen the way ping does?
I see advantage of replying once and replying once per interface, being a member of this group. But I have no clue to decide one.
So you're not against,
I'm not against reply on multicast group, yes.
okay.
Last question.
So Eric Normark, that was an interesting thing. Does that mean I can use this to send a packet to all the routers, and so I can find out who has this link local address? Because it has to match that target, right?
Oh, that's interesting. You could make the destination address a multicast and the probed address a linked local. I never thought of that combination.
And
I'm
now
wondering,
it will
why
tell
would
me
you
where
ever
it
want to
is.
do that?
Well, because it's some link local and I don't know where it is. It's sitting somewhere in the network. But anyhow, the reason I came up to the mic was, well, so I think this is good news, right? Because it opens up the extensibility mechanism to ICP echoes. And so far we only have it for errors, right? But this also means that you can put other extensions in there. And does the draft need to say something about those in terms of filtering them by default, part of the security thing, right? I don't remember what other extensions are defined, but.
Well, there are other extensions that would be ignored by XPeng. There are other ICMP extensions.
Yes.
But if XPeng got them, it would look at them and say, I don't care, and ignore them.
So, so they're sort of not defined.
Is there a scenario for both IPv4 and IPv6 that can ping each other's?
I'm sorry, could you say that again?
A third scenario for IPv4 could pinging IPv6 scenario?
So, sorry, there's that's in
Using any transitioning solution or something like that.
okay. You need to get in the mic line in the Mythical tool if you want to ask a question.
You didn't get my question, or should I ask again?
You need to get in the line. You need to request participation. We don't see any participants speaking right now.
And it's just a question. I don't see I don't see a third scenario, because scenario number 1 for IPv4 only, scenario number 2 for IPv6 only. What will happen when there are two different versions using any transitioning solution?
I'm not quite sure I understand the question.
Okay, no problem.
Okay, thanks.
I can try to clarify. There might be a question about, could the target and the destination be in different address families?
Absolutely. In fact, it's okay to send an ICMP4 echo request, and inside that, it identifies a probed interface by IPv6 address. So it's perfectly legal. In fact, it's one of the use cases.
We were cutting the line because we were really out of time. Sorry, guys, but we need to keep moving because it's taking too long to do. But Ron is calling for adoption. I
Yes,
think.
I'm asking for a call for adoption.
So let me get a quick feel from the group. There's interest and questions, but all those that would support adopting this draft in the Intarea, of course, with the hint of okay. We need to circulate in the ops area, but yes, please. First, raise of hands. Who has read this draft? Okay, quite a few hands. So Let's try to hum for people that believe that this draft should be adopted in the Intarea working group. Please, those supporting the adoption, hum now. All those that think that this should not be adopted, please hum now. Okay, thanks. Good indication. So we'll confirm on the mailing list. Thank you very much, Ron.
Thank you.
And then we need to keep moving. Yeah, it's Tom, right? Mark is moved to the end, so Tom. And we would appreciate if you could try to move it fast.
Hi, I'm Tom Herbert. I'm going to give an update on GU and ILA. Next slide. So the GU draft, this is generic UDP encapsulation. This was made a working group item, I believe, in Seoul. Since then, we had one pretty good review from Murray Kuchirawe. This resulted in several editorial changes, a few clarifications. We substantially cleaned up the normative language, the must and the shoulds and such. I'm asking here what the next steps are. Specifically, what do we need to get this into working group last call? Next slide. So the related draft is GU extensions. This defines kind of the basic set of first initial options for GU, security, checksum for GU, and things like that. So we haven't updated this version recently. I think we mentioned about getting this to be a working group item in Intarea, but we would like to get that into the Intarea also. Next slide. And lastly, ILA, this is identifier locator addressing. I think I presented this a couple times in this group and various other groups. So since Seoul, we added Peter Lampkov as an author from Facebook. There is discussion about applicability, ideas 5G, IP work. There is one issue that was raised that I think we want to address. Basically, we have a checksum neutral mapping as part of ILA in order to retain checksum correctness after translation. And we also have some other bits defined in the identifier. And the question was, do we need to do that at all? Can we just make 64-bit identifier flat space and not have these bits? And in the case of the checksum neutral, I suppose we would have to just say that per address domain, it's either on or off and not have any control bits. So I think what we probably do there is make the address types, which we have in the identifier types and the checksum bit, maybe make that kind of advisory and say that the identifiers can be a 64-bit flat space depending on the deployment. And our request here, officially make that working group adoption also.
Thank you very much. Okay, so we have already inherited one of the drafts here, and then these are companion drafts. So, well, I think it makes sense to consider them all together, but yeah, do we have any points, Lorenzo?
Yeah, Lorenzo Colletti. One thing about ILA that sort of just realized recently is that I think at least in its basic form, it only essentially deals in 128s. It basically only can, it provides mobility of individual IP addresses. And so, while we're on the subject of applicability, we should say that that's not recommended for assigning IP addresses to general purpose hosts. So if we take on this document, we should have an applicability statement to that effect.
So we did define the primary use cases of ILA, that is correct. It wasn't intended to be for the general purpose case. We are deploying it in data centers now, but it is specific what we're doing. We're actually, it's not even addressing hosts, it's actually addressing devices or tasks. So there is a little bit of granularity there. So we can clarify that.
Yep.
Okay, Suresh Krishnan, the AD hat on. One of the things that I think we talked about a bit earlier, and with Alia as well, is that like how much follow-up work is there for this, right? So is there like more work to be done for ILA? And the answer is usually yes, right? Because this works fine in a data center, like where things are under your control. But doing more stuff requires like other stuff to be done. And the Intarea, the way it's chartered, it's like kind of for like one-off work items, okay? So I'm really looking for some guidance from you, like how much follow-up work you see, because like the GUI, like it started off and then there's like the GUI extensions, right? Like, so if it's not a one-off item, it probably doesn't belong in Intarea. So that's like just a logistical thing, okay? I read the draft and I don't have like many issues with it, but there's like this certainly missing functionality that to make it work on the internet, right? And I don't have an answer yet, but I don't think we're ready to make the call for this document. For GUIX, yeah, go ahead with the call, whatever. But for ILA, I think we probably need to iterate a bit. And like, there's been like no discussion on this for like 5 months, like I think since October, right? Like for this.
Well, so my question right now is, should we just adopt it? More than that?
I didn't hear you.
There's been discussion in a lot of other contexts. Okay. I would point out that both GU and ILA are data path, and that implies we need the control plane. So, for instance, we just had the ideas lunch bath, and I think that would be great for the mapping subsystem, but that would also probably be in the routing area, if I'm not mistaken. Okay. So there is a larger plane of control plane that work that has to be done.
Okay, so the reason I was okay with taking on GU was like it's kind of like GRE-like, and like we did GRE stuff here, right, in Intarea, because there's no other home for it, right? And I want to make the determination independently for ILA than for GU, right? Like even though they're like all kind of related, like you say, but I just want to make the determination independent. So I'm fine with like there's no other home for ILA at this point, right? So I would like you to still continue discussing the stuff here, but I just want to have a better idea of like how much follow-up work is there to figure out if it's going to be here or should be a BOF, and if it's going to be a BOF, like is it going to be here or in routing? So that's the part I want to figure out before taking this up as a work group item.
So we did talk about that. I'm not sure that it would need its own working group. Maybe that's what your question is. I don't know how much more there is. So like I said, I'd like to restrict it to just be the data plane protocol. Mm-hmm. And then yes, we need some control plane. But as Lorenzo pointed out right now, ILA's primary first application is going to be in the data center, which looks a whole lot like an encapsulation in some sense. So we need that same sort of configuration, same sort of setup. Running on the internet is very possible. And because it's transparent IPv6, it actually makes it likely in some context. So what should we put this on the list, or?
Yeah, I really think we should take this up on the list afterwards. So go ahead with the GUI extensions, and then we like take this up on the list for follow-up discussion.
Okay. So for GUI, do you want to get a feel from the group right now, or? Okay. So please first raise your hands, those that have read the GUI extensions. This one that it's on the screen. Okay, a handful. Okay. All right. So then we'll call for adoption on the mailing list for this one. So next is okay. So taking off the chair's hat, I'm presenting here on behalf of my co-authors, editor Charlie Perkins, myself, Juan Carlos Zuniga, Dorothy, and Warren. So this is a draft that we worked few IETF meetings ago, and we discussed about multicast over IEEE 802 wireless, the different issues, and we got feedback from different sides. So what we have done now is taking a whole remake of the draft. So first of all, the draft right now has pretty much the same technical content, but now it's structured in a way that allows us to first of all describe what are the issues that we have observed when we use multicast over IEEE 802 wireless media, and then we highlight the features that are there to enhance this multicast performance, and these features can come from IEEE 802 or IETF, regardless. We also have some text that identify some operational choices that can be made to alleviate multicast issues. And the idea is to eventually provide recommendations about the usage and combination of these features for operational choices. So first of all, what we want to do is keep working with now this new structure and identify other enhancements that we might not have written yet. Especially we have in mind things written in 802.15, 6LO, etc., where there are other multicast issues that we have not captured. We want to talk also about the differences between implementations and capabilities between different access points, because what we may observe in 802.11 access point at home is not exactly what the behavior that we will see in one of these enterprise level access points. So we want to point that out and try to avoid making generic statements about the behavior of 802.11 in general. And we also want to start working on recommendations. So we are calling for feedback at this point in time. We got already some from Mikael Abramson, and that's appreciated. So we'll take that into account for our next revision. But definitely what we want now is feedback from you guys about more stuff to put in the draft and eventually come up to good recommendations. If there are no questions, then we can move to Carlos. Thanks.
Okay, I'm Carlos Bernardos from University Carlos III Madrid, and I'm presenting this work, which is basically just to make the community aware of implementation and a testbed for validating and measuring multicast over Wi-Fi extensions. So this is basically related to what Juan Carlos has just presented.
Could you speak a little louder?
Yeah. Do it like this. Better? So, well, this work has been carried out by my colleague Pablo and Francesco from University of Brescia. So basically, just a first overview of what the extensions of .11AA do in terms of multicast. So basically, there are four mechanisms or four approaches. Just a very quick reminder: the legacy one, which is the way 11.11 multicast is transmitted, is basically you transmit the frame using a low MCS, and you don't have any proof or any acknowledgement that the multicast frame has been received by all the receivers. And then there are three different improvements. One is basically to transform this multicast frame into unicast, and you send different copies, one per intended receiver. This is, of course, very reliable, but it has a lot of overhead. Then you have another approach, which is basically you send the multicast packet, several times, in trying to improve the rate of the success in the receivers getting the packet. And then the last approach is what is called block acknowledgement. Well, basically you send a block of packets and you then ask for the receivers to say whether they receive or not, and then you retransmit those that has not been received to the receivers that didn't get the packets. So these are the four extensions. Here is basically just a summary. Of course, you have a trade-off in terms of complexity and in terms of reliability. The more complex, the more overhead you have, the better in terms of reliability. And then having this approach, this is basically technology defined by IEEE. We had a testbed in order to first implement those extensions in Linux and then to validate and to assess the performance that we can obtain. So we have this testbed with around 30 nodes. All the tests has been performed using channel 14 to avoid some interference, although we also did some tests in channel 11. For the block acknowledgement approach, we explore different values of M. M is basically the size of the different blocks of packets that you send. And then for the unsolicited retries, we try with different values of number of retransmissions. So 0 is just one single transmission, the legacy mode. 1, you transmit 1. 4, you retransmit 4 packets, 4 times the packet. And then for the MCS choice, for the legacy, we set that to 24 megabits per second, and for the different extensions, we use 54 megabits per second. Then we did a set of experiments. The first one is basically we have a multicast CBR traffic over IPv4. We have 10 receivers of that multicast traffic, and additionally in the network we have another 10 stations transmitting just regular unicast data. And then under this scenario, we basically look into two performance figures. One is the video delivery rate, so the multicast delivery rate, and another one is in addition, the aggregated data traffic that the network is able to transmit in addition to the multicast traffic. Here we have different results. The goal is not actually to go into the results here, and in the interest of time, I will just quickly go through those, but basically just to show that, for example, when we have the block acknowledgement approach, this is the one that provides the best results in terms of video delivery rate as expected. And then we have here in yellow the legacy approach, and in red the one about the unsolicited retries. With R0 should be basically the same thing than the yellow one, but the difference is because of the MCS, the different MCS that is being used. We have a results for channel 11. We have also results for the data traffic. And we have also a different set of experiments using real video with full HD video with a varied rate traffic. And there we also evaluated under different scenarios. So again, here we have the results, not the goal for this presentation to go into the actual results or the analysis of the results, but just to show the different things that the testbed allows to be proved. So this is the stuff that we want to just to make you aware. There is an implementation of this that is open source, so you can get the open source implementation of the 11AA extensions for Linux. There is ongoing work now moved to Brescia, to University of Brescia, looking into additional things. And basically what we wanted to ask here is for feedback in terms of things that this testbed could be used for in order to assess, for example, the multicast extensions that Juan Carlos was mentioning before. There may be things that we could prove there, and in order to basically compare different approaches that could be used for multicast over Wi-Fi. And there are some pointers if you want to get more information. Of course, you can also contact me directly or my colleagues if you want other information. So questions or comments?
So I have a question on the previous slide, this one. You said that the ongoing work is to test some other multicast enhancement features, or
well, basically, there are different things there, but in addition to this, we can use the testbed, for example, to show the issues that are in the draft, in the multicast draft. We can try to emulate the same scenarios, IPv6 signaling, for example, and to see, okay, with the legacy, this is the performance, those are the issues. Then we try to put one of these extensions or others. I guess these guys are open for implementing other stuff if considered useful. So we are open to basically compare.
Is the testbed isolated, or can it be mixed with real traffic or other type of traffic? Or
the traffic that we can put is, I mean, you can put any kind of traffic there. I mean, we can use synthetic traffic. We can try to put real traffic with real users.
It's still a testbed that is isolated from the one that is serving the campus.
Yeah, but it's it's isolated, so it's not used for regular internet connectivity, but it's on the building. So at the end of the day, the interference, all the stuff.
Okay, so the radio is coexisting.
Yeah.
It's just the back end that is isolated. Okay. Thanks, Lorenzo.
Lorenzo, good. Yeah, I may have missed this, and you may have said it already, but did you or did you not test? Because I see performance numbers with data-heavy multicast, but have you been testing with the small packets that are IPv6 control packets, NS and RA?
I think that these results are basically focused on video transmission, so no small packets. But actually, these kind of requests are the ones that they are interested in. Like, do you think this is valuable? They are all open to try these kind of things with small packets, NS, NR. So this is basically what they want. If you think we can try, yeah.
Because I think that the scaling characteristics are very different. Here you can do a lot of optimization by like aggregating the packets into one big blob and maybe using fewer TX ops or whatever. But the sort of control traffic is probably more spiky, and the packets are really small, so it might become inefficient because if you can't aggregate them into bigger packets, then it's expensive. I don't know.
Yeah, I fully agree. So, I mean, that's the whole point is just to have a framework to be able to assess that in a real environment.
Thank you. Eric?
Okay, so I'm about to present you work we have done with Basil, Tommy, Pierre, David, and myself, Eric Vinky, I'm the last one, and you're my last name. So, quickly, what are we trying to solve? What we are trying to solve is basically going back to the basic. There are multiple v6 addresses per host. You can have the link local, the global, multiple global. We all know this, right? So what happened in a network like this one? Typical multi-homing for small and medium business, where you get 2 egress to the internet, and you receive 1 prefix red, 1 prefix blue. So on the top, the PC select the source address blue, exit by the blue router, everything is fine. You get the story. If you take the same address blue and exit by the red router, hopefully the red ISP is doing BCP38 and will drop the packets. That's thanks God for the internet, but that's pretty bad for the user. So how can we solve this? First, there are some enforcement telling, hey, if you use the prefix red, please use the next hop as being red. Does not solve the problem if you have multiple layers of routers, because you can only select the first one. Then after, there is only one default route normally. So you still have the problem. But it's not enough. Assume one of those links is linking like a VPN to your company. Now you have 2 DNS servers, one from your company and one from the internet. And I'm working for Cisco systems. So if on the VPN, the resolver that I receive through the VPN, I ask www.in for inside the cisco.com, I will get an answer. If I ask my ISP for the same name, I will get no answer. So that's more than the address and the routing there. That's only one problem. And the other issue or potentiality is that if you have different kind of network services, think, for instance, quality of service. Now, whether they are done by traffic engineering or they are doing by classification and this code point, for instance, there is different level of services. Now, you can say, based on the source address, you have 2 prefixes, red and blue. The red, you have no quality of service. But if you say the blue, React, you classify your packets hop by hop, kind of like this serve code point, this serve. But at least on this one, you cannot change the address. The serve code point, we've seen this morning at MapRG, can disappear. At least your IPv6 address, the source, does not change on the path. So there are ways of using the prefixes to select the service. And that's basically what this kind of graph wants to say. Hey, Mr. Application, yes, you do have, if the router advertises different services based on the source address, you may select different kind of quality of service or quality of experience. Sounds logical. But have we done this before? Yeah, sorry. Yes, all of us, whether it's iOS or Android, have got phones where you can select this application may use or may not use the cellular link because it's expensive most of the time. There's a reason why handset OS vendors typically do it. So we have already the knowledge that application by application, you can use cellular yes or no. So they could do and extend it. Hey, please use this source address or that source address, basically to select the network service. So now I'll slow down. Provisioning domain, PVDs. That's not a new concept. It came from the MIF working group as well. You get multiple interface, on each interface multiple routers, and on each routers you can advertise multiple prefixes. So very multiple prefixes you can get. PVDs are the set of a PVD ID that you can use to glue all the set of information. Think about it at the first level as an index into a database. It links the prefix, of course, the next stop, the DNS information, as I told you, hey, can you look for inside DNS or the outside DNS? But also, for instance, and there are other working groups that may be interested, is there a captive portal here? So I don't start the application immediately to go there. Do I have access to the internet globally? Or is it just a walled garden just to look about the movies in the plane or in the train? That's also important to know, right? And you can also get, is it free of charge or not free of charge? How do we communicate this set of information? And we are in 2017, so it's IPv6 only solution, right? So we are sending what we call a bootstrap PVD into the router advertisement. And it's important. There is no round trip time. You don't need to do more thing of probing or fetching information. In the bootstrap PVD, you get enough. We assume that the PVD applies to all prefix information option into the array. If you want to advertise different PVD, you will need different prefixes to be sent in different arrays from different link local address. Eric.
Is it okay? I can wait.
Oh, you can wait, okay. So let me finish it. And then we can also put into the array what we call advanced information condensed, of course, right? We are limited to the 1K or a little bit more of the array. And we put it in a sentence like this. Again, that's a proposal, by the way. That's a -00. So I guess, Eric, if it's only here, maybe that's a good time.
I think you have to say, instead of only applying to PIOs, oh, sorry, Eric, fine. Instead of saying only applies to PIOs, it has to apply to all the information in the array. That's got to include the RIOs and the RDNS and DNSSL options as well.
You are perfectly correct. In the draft, it's a little bit better explained than this.
Always nice to hear. Thank you.
And thanks for the confirmation. Suresh.
Yeah, so Krishnan. So having seen this train wreck many times, right? And I'm just wondering how, okay, how are things going to go differently this time? Sorry for being skeptical here, right? But where do you think the differentiation is? Like, because like Yoni here is like smiling as well. We've gone through this like stuff ourselves, right? And so either it's a question of like how much you want to cover. For example, already like, RDNSS is there, right? So there's going to be array options coming in the future, and they might need to be contained or not. So, and that was the biggest issue that sank like what was in there, because like if you have a tightly scoped small set of things, it becomes doable. If you want like a broader scope of things to go in there, it becomes very difficult, especially if you don't know what's going to go in there, right? So yeah, Mark, did you want to say something on that slide?
Okay, so on this one, the mechanism here is pretty simple compared to other ones that were much more complex. And what we send is the bare minimum, right? The PVD ID. Next slide, I'm explaining what we can do more. But all the sentence that I put there, the string, is extensible, basically. So do not need to define like TLV again in another draft or another TLV and so on and so on. And whether you support it or not, it's up to you, right? The router should never rely on the fact that the host is able to understand it. I am offering it to you, this information. You don't take it, that's fine. Nothing will break.
Right. So that's how like we started off as well, right? And one of the things that came up was like people said we need some trust in the person telling us this thing would make. Then you had to add like a signature option on top of it, and so on. And people said like, oh, text things are like so 19th century. We need something more. Like we need UUIDs, and that's the slope that like we're gonna go down on, and because everybody wants a pony, right? Everywhere, and I think that's. I'm not sure where to draw the line, and I think this line is like too.
Okay, we need to find the right balance. Now, regarding the security, next slide, I have more on this. Okay. Just on this, of course, there is not enough security. There's a reason why we get the second stage PVD. right? But with this, you can start the interface, you know you have captive portal, I don't select this one, I select this one, and I go cellular, for instance. Tommy.
I'm going to talk about you, Tommy.
Go for it.
Real
Please
quick,
do.
Mark Townsley. Suresh, you mentioned, why is it different this time? And this has been around for a long time, but in different forms. I think two of the reasons, and now three, you're standing at the microphone over there, is that, well, now there's two of them. And that's the host vendors are very seriously looking at this. And this is something that I think is, not that they were ignoring it before, but I think it's pretty serious this time. And also, speaking on behalf of my company, we're starting to see enterprise networks that are seriously motivating us to deploy IPv6 only, and we're setting that up. I think IPv6 only is sort of a predicate for this to even really be thought about and done properly and take off. And we saw data from this morning in MapRG that 3% of the of the hosts that Tommy sees are v6 only. I think I just stole his thunder. I'm sorry. Your turn.
No, that was Tommy Pauly, Apple. So I agree with all of that. I think some of what's different is, yeah, we do have more v6, we have more other things. I think what it comes down to is also there's more of this multiple PVD stuff that's really going on, and that we want to be able to actually distinguish not just between, oh yeah, cell and Wi-Fi. That, like, we figured that out a couple of years ago, but there are more cases in which we have these two different uplinks off the same router. We have home net stuff going on. It's getting more complex, and that's becoming more of a reality that we need to solve. I get the point that, yeah, everyone wants to put their pony into the RAs and stuff more stuff in. To me, as one of the authors, that's not the main point of this. That is something we're trying to open up. The main point is that you have multiple PVDs that you know about explicitly. And so even if you just look at it as I have different prefixes, and I know that these different prefixes go to different uplinks, and that's all I know, and there's no extra metadata, that's still really useful to know that these are two different things.
Yeah, Tim Chan, no, I agree with everything Mark said. I think maybe it's the time is now much more favorable for it. There was certainly a lot of feature creep in the earlier MIF work on this. But there was also some good ideas, things like implicitly determining PVD. So you don't necessarily have to have it in your face from an RA. You can deduce the existence of a PVD from a set of information that you get. So I think that's the sort of thing that if you're going to do incremental deployment ought to be considered as well.
Yeah. Lorenzo Culiti, I think, I mean, to Suresh's point, I think that optional information has got to go. But there, like we thought about this as well. I mean, I'm not one of the authors, but we had a discussion about this, and to me, it's extremely important that the information that's given to you at the earliest possible time is can be applied to a given PVD. So we don't want the situation where you get an RA and then you have to, like, there's a race condition with you fetching other information from other sources to figure out which PVD that's in. There's got to be an ID in the packet so that as soon as you start to do the first provisioning operation, which is maybe like literally send a DAD code for your address, you need to know that. And I think we should limit it to the smallest amount of information possible. And for the question about like whether tomorrow's pony should or should not be part of this particular PVD, I think that's something where we can look at the existing options and say these are hereby PVD specific and these are not. And we can try to say future options should in their document say whether they are or are not part of the PVD that's in the RA if any such option is present. I think we can fix these issues. I think part of there was, I seem to recall that there was an issue with putting this stuff into DHCP4, but that shouldn't apply here.
Can we move on?
Eric and Eric and Eric. So which one? Pick yours.
I'll defer to Nordmark.
Could you guys be brief in the interest of time, please?
Yeah, Eric Nordmark. So one thing that isn't, so I know that people have done stuff with different classes of interfaces on phones, right? But one thing that I wonder about is what's the intended scope of this to impact all of the other applications in the universe? Because if you have this stuff and for it to be useful, it means that everything running on your laptop will need to know about these things to be able to give you the selection menu that we have on the phone, sure, right? And does it mean that every of the billion IoT devices will need to know the same thing? It's like they don't have user interface to do that. But where does this lead us on the application side, not the network stuff, right? Because that's where and on the phones that work has already been done. But are we going down a path where even if you're connecting into wired Ethernet, all of your software needs to know about this stuff for it to work?
No, Eric, if there is no specific request from one application, you select whatever you want there. That's right. So you are back to the source address selection as usual.
So to answer, if I may, Eric Klein, if I may address your point directly, I mean, in the MIF working group, I had a PVD API document, a user space API requirements document. If this is to be adopted, I would happily resurrect that and bring it here. The MIF working group was shut down for a variety of reasons. But
I think we're cutting the line. Sorry.
So,
another quick point, please.
Yeah, I was going to reinforce Eric's point. The reason you can cite the phone example is that there is a very simple user model for the phone. And also it's tied to something people understand very well and pay. There is not the same kind of user model for a generic network. In particular, what you said about selection, it's not on a single network. If my laptop moves here or there, I mean, the network I move to will be multi-home too. So am I supposed to put not only one line that says, oh, this or that, but on this location do this, on that location do that? I mean, it becomes completely, I mean, unmanageable, okay? So I don't think having the idea that the user will actually poke into that data and make decisions is completely unrealistic.
And you're perfectly right. If you wait for 2-3 slides, there is a project called NEAT where a couple of people here, including Gary, at least maybe others, are working on to provide something which is not related directly to this PVD, but leverage them. Okay, we thought about it. Yep. So quickly to finish the 2-3 slides, and I guess will be enough. So that was, the bootstrap PVD. Then we get the second stage. We put in the ID couple of proposals because within the others we don't agree how to get the second stage. Could be HTTPS, and that's part of it where we get some security because with what we get by HTTPS or by DNSSEC, we get the prefix again. So we can kind of close the loop. It's not fully secure, but it's a good level of security somehow. We need to refresh the accept language and blah, 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 blah. We can skip this. The information, we don't really talk about it, about the captive portal, where do you get access to the internet. If you are NAT, what are the NAT timer? If you're using NAT 6.4, for instance, what are the NAT timer for UDP? So that's important for timing. Again, you don't want to take this information into account, your choice. But if you want, it's okay. We could even, and that's with a couple of question marks here, right? Link this to IPv4 information. If you receive one PVD from one MAC address, and you only receive one PVD from this MAC address, then you can make the link with the DHCPv4 information sent by this MAC address. Okay? Or into the big JSON on the big STXC record, you can say, hey, the DHCP server v4 is this one. So we can make the link between augmented information, the second stage PVD, with the RAF bootstrap DHCP v4 PVD. That's one way of doing it. And on some lines, like 3GPP, you have no choice, right? There's only one interface, so one router on the end. So there is running code. It has been some tests done by Tommy, an hackathon a couple of times ago when you're getting two routers, and we can select, hey, even if they were both over Wi-Fi, was back on a cellular uplink. So when the cable modem, which was cheap, was done, some application can disconnect. So that's over Wi-Fi, right? So there's not the normal cellular. That's Wi-Fi connected backend over cellular in this case. Somebody changed as well the Firefox to understand this multiple of PVDs. Example, to come back to you, Eric and Christian, on this. And the NEAT project, you can get the pointers. There's much more because not only selecting the source address, but also the destination transport protocol v4, v6, so that's quite convoluted here. Anyway, not to burn all my time. Next step, We present this as well to V6 Ops. As well in later Tommy presented to the captive portal working group because it's a lot. But we do believe the authors that this is the group where it belongs to. So we expect some comment, reviews, and hopefully being adopted as a working group item. Suresh.
Suresh, yeah. I think you should continue discussion on the list. I don't think it's ready for even deciding whether it's ready for adoption or not. So I think continue discussion on the list and see how things go, because I don't want Intarea to become myth. Okay, so if there's like more work that's coming up, like I would really like to keep that separate again, because I don't want to, like, you know, like Terry to come and claim Intarea. I'm just kidding, but I really think this requires like a lot more discussion, like before we go forward. So I think it's a bit premature, but I think it's worth discussing in Intarea. I think it's a good place to discuss it.
Okay. Last point,
Yeah, Eric, I would suggest to go to the apps area early as opposed to late, because as opposed to them finding out 3 years down the road, you did what, and you expect the applications to deal with, go there now, right? And see, do you think that this is reasonable for the apps? They're already, some of them are already doing it. So maybe they think this is helpful, or maybe they think it's a bad idea, but finding out earlier than later is a good idea.
That's a pretty good point.
Thank you. Okay, so let's definitely take this feedback back to the list. Mark, now that you're back in the room, could you please take over?
There was a comment from Dave Taylor about one of the previous presentations. I don't know if we want to take it right now, or do you prefer if we take it to the list? There's a comment about multicast over 802.11. And Dave says, my comment on multicast over 802 was that I think that draft should also point out operational issues with weird AP implementations that block multicast to UDP ports other than a specific SIT. For example, the MDNS port, and thus interface with application protocols. App protocol designers should be aware of that. And he also says that's 802.11 specific, but this draft seems as good a place as any to call it out.
Okay, thank you very much. Mark? We'll take that feedback into account.
Hello, everyone. Hopefully my co-author, Joe Touch, is in the Jabber room, et cetera, et cetera. I'm, of course, presenting this on his behalf as well as mine. This is a document that's been around for quite a while, has had sparked a lot of discussions and debates, and digging through various piles and piles and piles of RFCs and documents for terms and things like that. And this is a status update. It's not a fun, exciting presentation that I gave on this a couple of years ago. Why isn't this working? Ding, ding. I actually want to go to that slide, update summary. Oh, this is really awkward. You can look at my back. So there was a version 4 that was posted just before the deadline, and then a version 5 yesterday or day before, with a bit more nits and such fixed in it. There was a terminology scrub where the aim was to dig through the archives and use past terminology for things mostly around MTU and such, and associated references in the RFC series, and only invent new terms where absolutely needed because it hadn't been identified as a separate term in some other past document. Clarifications, reorganizations, fleshed out some of the existing protocols issues, where we can identify that some existing tunneling protocol doesn't match this tunneling model that we're trying to define. A bit on load balancing, and a summary of recommendations, which is in section 5. And that relates to the current status, some of which I've already given you a review of. But the real question that Joe and I would like the answer to is this third bullet point, which is, what's the path forward? This is already obviously a working group document. If the working group wants this to become a BCP, we will do the extra work to flesh out section 5, which gives recommendations. If the working group does not want this to be a BCP or sees some problem in it getting published as such that's, can convince us that it would be a waste of time, we will delete that section or most of it and focus on the informational aspects, which is sort of, pulling together this model description based on the past tunneling that we've done in the IETF. I don't think I have time, and I don't have Joe here to go into details about this version. I very much would like people to review it and make those comments on list. And Joe and I committed to, within a couple of weeks after some decision on BCP versus informational, we'll give you the next revision and be active as long as the list is active in order to get this moved forward. Hopefully by a working group in Prague or the next IETF. But we kind of need to know the answer to that fundamental third bullet and would like input on that if you're willing to give it here today.
Thank you very much. So I guess you should shoot it out on the mailing list. We don't have, as you say, much time right now to discuss. But definitely that's the question to answer, the BCP or not.
Okay, that question has been already asked on the mailing list, so please respond and let us know. Thanks.
Thank you very much, Mark. So next is Suresh.
Okay.
Khaled, are you?
Khaled, just a point of order, like you have a 5-minute presentation slot and you have 16 slides. So use the time however you see fit, but you're going to get 5 minutes, okay?
Okay, I'll try to distribute them equally for all the slides. So today we're going to discuss the IPv10, and for the first time, people think that IPv10 is a new structure for the IP version. Actually, it's not. It's a solution that will solve the problem that I'm going to discuss on the slides. First of all of you know that the address space for IPv4 is 4.3 billion unique addresses, and the fast growth of the internet started to make this address space to be exhausted. And actually, let's go to the next slide. All the 5 regional internet registries after IANA, almost all of them announced the depletion of the IPv4 address space, which is a big problem that we are going to discuss next.
Francis Dupont, for IPv6 is 95, not 98.
Thanks. Right. We have a technical issue here. We lost Khaled. Okay. So when he comes back, we'll come back to this presentation. Meanwhile, the next one online is Jordi. Oh. Khaled, can you talk now? We cannot hear you. No, he's a remote presenter, so make sure your microphone is not muted. It should be blue, not gray. Okay, so let's try with Jordi Wow.
I can make it in 50 seconds. You want? Okay. Okay. Well, first question: why we are presenting this here? We believe this belongs more to B6 ops, but B6 ops don't standardize new protocols, and DHCP don't standardize new options. So we need to be in the middle of nowhere. So okay, let's see. I cannot see the slides. Basically, the point here is we have different transition mechanisms that use NAT64, either stateless or stateful. And in some situations, you may need to have several NAT64 boxes. and we need a way to tell the clients we need a way to provide the information to the clients about what are the prefixes, both IPv4 and IPv6, that those different NAT64 boxes are able to handle for them. Basically, what we see is the need for IPv4 destination routing depending on the box you are using, okay? The proposed solution is basically the same as any other DHCPv6 option. I am not going to explain the detail. We don't have too much time. I think it's very detailed also in the draft. We have updated it just a couple of days ago. We have added the main difference with the previous version is that now we are also incorporating suffix information following the NAT64 standard. Basically that's it. We are seeking for a working group adoption and to move forward. We believe it's even ready for last call. We received just a few comments in private. We incorporated them, and I think it's done if we go for a working group item, and we can go immediately to last call.
Thank you very much.
David Skanazi, Apple. So there is a mechanism for detecting or being formed in NAT64 boxes. It's documented in RFC 7050 and it uses DNS.
Yeah.
Why add another one?
But if you have different routing destinations based on IPv4, that doesn't work. That's the reason, that's explained in the draft. That's the reason we needed this option.
And what networks are deploying this?
Sorry?
We're cutting the line.
Yeah. What networks are deploying this? Well, what's kind of the goal of having this scenario you described?
The goal is to be able, for example, to have different NAT64 boxes in the same network that are handling the traffic for different IPv4 destinations.
You can use IP routing in the network to do that, right?
You can use, sorry, didn't hear that?
You can use IP routing in the network once you hit the network,
could
right?
do with routing, yes, but we believe it's simple doing this with a DHCP version 6 option, and that's the way typically we do everything.
Tommy Pauly, Apple. So I'm also having a little trouble understanding kind of what the use case is, especially for the host. Kind of going back to what we were talking about with the PVDs before, it seems like if we actually wanted to know about multiple NAT64s and how to use them differently, that's really a case in which we really want to know, like, I have two different networks I'm managing, and that becomes that bigger PVD problem. Maybe in the PVD world, we have this and we know what the different things are, but just adding it to DHCP, I don't know how that's going to be useful on a given host.
Okay, so I think we're cutting the discussion now.
Just
Please.
one last short point, sorry, David Skanazi. To answer your point where you said, well, this is DHCPv6, that's how we do everything. No, it isn't.
Well, I mean, yeah, you're right, but if we want to make the things simple, this is the best way. Well, okay, let's move to the list, I guess.
Yes, please. Thank you. We didn't get back Khaled. Okay, so we move now to SDN multicast.
Hello.
And please be brief.
Thank you. All right. I'm here to present SDN multicast overlay.
Could you please try to stay in the pink?
Oh, sorry.
Just for the camera, the pink.
Oh, pink box.
Thanks.
Thank you. First time. On behalf of my co-authors, and my name is Dave Key from Bloomberg, and my co-author Nabil Batar also in the room. My other co-authors, Truman Boyce, Senat Palestimovic, and Anil Lohira, not here right now. Sorry, next time. So we want to fix it. The outline basically we want to talk about four things. Number one is what is the problem statement? What are we trying to solve? And What is requirement for SDN multicast framework? And number three, what is the proposed framework? And then we'll talk about the next steps, right? Excuse me. So first of all, what's the problem statement? What's the problem in today's multicast solutions? And number one is there are various multicast stability, scalability, and negative impact to unicast. Nothing to mention complexity of the multicast protocol procedures, right? And some of the multicast protocol procedures are they have periodic state refreshes, and some of them are very chatty in terms of the receiver joins and leaves. In addition, the distributed multicast control states are taken away from the unicast resources, right? TCAMs and bandwidth, etc. And number two, the lack of a uniform multicast admission control and really a fine-grained path computation mechanisms across implementations, right? So basically, there's no unified admission control for senders and receivers. There's no really fine-grained bandwidth computation. If you want to do diversity, if you want to do QoS computations, if you want to think about latency and jitter, all those things, today's multicast path computations does not provide.
Hello, can you hear me now?
Yeah, sorry,
I'm
Helen,
sorry,
we're
but the mic was enabled suddenly.
So, sorry, we're at a different presentation. Dave,
Okay.
we're out
Sure.
of time, so if you can
Okay.
summarize in about a minute.
I got you. Sure, I'll be quick. Number three, restrictions and constraints that carries multicast across multiple administrative boundaries, right? It just doesn't exist if you want to take to end-to-end multicast delivery from your data center, your wide area, and your wide area network, your campus. It just doesn't happen. Number four, the inability of the operators to flexible design multicast requirements and delivery, and doesn't have to base down your underlay restrictions and your operators' requirements. That level of abstraction is not there. Number five, the lack of uniform security, multicast security policies, right? I mean, not to mention DDoS, but whether it's malicious or not, those type of multicast security mechanisms are not provided in a uniform fashion. And number six is really lack of multicast telemetry information in a very fine-grained detail fashion. So what's the framework? What we try to solve? I mean, what's genesis of this SDN framework? We want to provide for a decoupling of a multicast control plane from the routing forwarding entries and unicast, right? And number two, a unified control plane across various forwarding element implementations, whether you have.
I think we're really out of time. You really need to summarize. If you want to get the last word in, do it now, because we are 3 minutes over time. Okay, so get to your slide 11, I think, and then talk.
Cool. I'll be very quick. Thank you. So, sorry.
Yeah, you're.
Okay. So basically, we're here to solicit feedback for the draft. And obviously, it's all draft and it's really raw, and we like people give feedback. Number two is, we want to obviously add more contents for tolerance and more for example, multi-provider PPI interface, etc. And lastly, we just want to make sure that this is a interesting topic, and people are I like to work on it. For example, thank you.
Thank you very much, and thanks to all the presenters and people participating. Apologies for the people that did not get a chance to present, but keep in mind that this is meant to be a discussion on the mailing list, so continue the discussions and any points that may be missing on the mailing list, please. And thanks a lot for attending.
Hello?
usually leave the stuff here, right? Someone needs to find it.